Hello everyone, welcome to the course on chemistry. In that we are discussing about surface chemistry. So, in the previous video, we have studied about the classification of colloidal solutions based on different categories. That is based on physical state of dispersed phase and dispersion medium, we have classified the colloids, and based on the type of colloidal particles, we have classified the colloidal solution, and also based on the nature of interaction between dispersed phase and dispersion medium, we have classified the colloidal solutions. So in a type of particles which are present in the colloidal solutions, we have studied three types of colloids. Those are multimolecular colloids and associated colloids, and another one is macromolecular colloids. So here in associated colloids, at lower concentrations the electrolytes will not form the colloidal solution, but when they are present at higher concentrations the electrolytes will form the colloidal solutions due to the aggregation of molecules, and those associated colloidal solutions or colloidal particles are also said to be micelles. And today we will discuss about the cleansing action of soap that can be explained based on the formation of micelles. Due to the formation of micelles, the soaps are able to clean the cloths or dirt which are present. So how does this cleansing action of soap will takes place, that we will study now. Here, as you know, soap consists of the sodium stearate molecules. Here you can observe the long chain, okay, and at this end you will observe COO minus Na plus. So two parts are there in this sodium stearate ion. That is, one end is tail and another one is head part. So the tail part is said to be hydrophobic, and end part, that is head part, will said to be hydrophilic. Hydrophilic means it is attractive towards water. Hydro means water, philic means attraction or loving. So hence this head part is water attracting or water loving, and this tail part is water hating, means it will get attracted to any other hydrocarbons. Okay, so how does this leads to the micelle formation? Due to this special structure, they are able to form the micelles. How does they will form the micelles, that we will study now. As you know, the associated colloids are also called as micelles. Now that micelle will be formed at particular temperature and particular concentration, and that temperature above which the formation of micelles takes place is said to be Kraft temperature, and the concentration at which the formation of micelles takes place is said to be critical micelle concentration. Now how does these micelles gets formed, that we will study. ಯಾವ ರೀತಿ ಮಿಸೆಲ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಾವು ಅನ್ನೋದನ್ನ ನಾವೇನ್ ಮಾಡೋಣ ಕಲಿಯೋಣ. ಮಿಸೆಲ್ಸ್ are the cluster of particles behaving as colloidal particles, and these micelles are formed usually when soap is dissolved in water. It consists of sodium stearate ion consisting of hydrophobic end and hydrophilic end. Now the soap molecules, when the concentration gets increases, they starts to associate with each other, and the hydrophilic end heads towards the water and hydrophobic ends present at the center. This is how the micelles gets formed. As you come to know the micelles formation, here at low concentration the hydrophilic end heads towards the water, and the hydrophobic end, it will move apart from the water. So this is the arrangement observed when the micelles are at low concentration, and when there will be presence of higher concentration of electrolyte, the micelles gets formed in this manner. Now if there is a presence of dirt or oil in an substance, then what happens? If you observe here, the head part, it is hydrophilic, it will move towards the water or heads towards the water. But these hydrophobic ends, they will try to move from the water, and hence when there is a presence of dirt or oil, these hydrophobic ends, they will attracted towards the oil or dirt. Usually, you know, oil or dirt, grease, if you consider grease or oil, they are almost the hydrocarbons, and hence they are attracted towards, these tail part is attracted towards the oil, and hence they try to attract the oil particles towards it, and hence when you rub the cloth which is dipped in the water, upon rubbing, the oil particles will come along with the hydrophobic part of these micelles, and hence these oil droplets will remain in water and the cloth get cleaned. So this is how the dirt or oil will be removed by using the soap, and that can be explained with the help of this micelles formation. So this is how soaps are used to clean the substances, or it acts as a cleansing agent. We will move to the next concept, that is preparation of colloids. So in case of lyophilic colloids, you know that if we simply mix the two solutions, it will forms the lyophilic colloid. But when there is a presence of lyophobic colloids, how we can form that? As you know, they are not formed simply upon mixing. And in order to prepare those lyophobic colloids, we will use different methods. So one of them is chemical method and another one is physical methods. So first we will study what are the chemical methods of preparation of the colloidal solutions. So here the chemical methods involve double decomposition, oxidation or reduction or hydrolysis. By using any one of those, we can able to prepare the lyophobic colloids. So first one, double decomposition. In double decomposition, the hydrogen sulphide, that is H2S, is passed through a solution of arsenious oxide in distilled water. We get a colloidal solution of arsenious sulphide. Okay, so here it is chloride, it is not chloride, it is sulphide. Arsenious sulphide will be formed upon double decomposition. Okay, simply we will take the arsenious oxide and we will pass the hydrogen sulphide gas. On passing that, the arsenious sulphide solve will be formed. So here the double decomposition of the molecules will takes place. Double decomposition ant helidre arsenious oxide will also undergo decomposition and hydrogen sulphide will also undergo decomposition. First they will split up into two different atoms or molecules, then they will rearrange and forms arsenious sulphide salt along with the water. Okay, so double decomposition ant helidre alli enagtavri arsenious oxide ಏನಾಗುತ್ತೆ ಸ್ಪ್ಲಿಟ್ ಆಗಿ ಅರ್ಸೆನಸ್ ಮತ್ತು ಆಕ್ಸೈಡ್ ಅವು ಫಾರ್ಮ್ ಆಗ್ತಾವು. ಆಮೇಲೆ ಹೈಡ್ರೋಜನ್ ಸಲ್ಫೈಡ್ ಇದ್ದಿದ್ದು ಹೈಡ್ರೋಜನ್ ಮತ್ತು ಸಲ್ಫರ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಆಮೇಲೆ ರೀಅರೇಂಜ್ಮೆಂಟ್ ಆಗಿ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ರೀ ಅರ್ಸೆನಸ್ ಸಲ್ಫೈಡ್ ಮತ್ತು ವಾಟರ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ವಿ ಗೆಟ್ ದಿ ಅರ್ಸೆನಸ್ ಸಲ್ಫೈಡ್ ಸೋಲ್. So don't bother about the mechanism. Here you have to simply remember different chemical methods used for the preparation of colloidal solutions. So if they ask, write two chemical methods of preparation of colloidal solution, you can simply write the double decomposition and oxidation, or also reduction and hydrolysis processes are there. Among them you have to write any two and simply write the equation. Then second one, oxidation technique. What happens during oxidation? Here a colloidal solution of sulfur is made to pass through an aqueous solution of sulfur dioxide. Okay, so hydrogen sulfide here I have taken. When this hydrogen sulfide and sulfur dioxide are mixed with each other, okay, that is simply we will pass the hydrogen sulfide to aqueous solution of sulfur dioxide, and at that time we will get the sulfur sol along with the water. So this is how we will form the colloidal solution by using oxidation. Sulfur sol. How to prepare sulfur sol? If they ask, you have to write this. How to prepare arsenious sulfide sol? Then you have to write answer, double decomposition technique. Okay. Then third one, reduction technique. It is another technique of preparing colloidal solutions. Here I have taken the example of gold chloride, that is Rm chloride. When it is treated with formaldehyde with water, then it will undergo reduction to form gold sol along with formic acid and hydrochloric acid. So here reducing agent is formaldehyde. Formaldehyde will act as reducing agent, and hence Rm chloride will gets converted into Rm and forms the Rm sol, that is gold sol. In the similar manner, we can also prepare the gold silver sol as well as platinum sol also. Okay, so this is another technique. Then fourth one, hydrolysis technique. Hydrolysis means we have to simply add water. So it involves the use of boiling water to obtain a reduced solution of ferric chloride. So what do we do here? Ferric chloride is taken, okay, and here we will use boiling water. When ferric chloride is added to the boiling water, then it will form the ferric hydroxide solution, that is the sol. Okay, so ferric hydroxide sol will be formed along with the hydrogen chloride. So this is how we obtain different kinds of colloidal solution by using different chemical methods. So these are the four different chemical methods which are given to you. So remember these four methods to prepare the lyophobic colloids. Now we will study some of the physical methods of preparation of colloidal solutions. The first one is electrical disintegration, or it is also known as Bredig's arc method. So this is one of the physical method which is used to prepare the colloidal solutions. What happens in this method? Here it is mainly used to prepare the gold, silver, platinum sols. Okay, mainly metal sols are prepared by Bredig's arc method. Here what we will do is simply the metal sol which is to be prepared, we will take the electrodes of those metals and we will immerse that into dispersion medium, that is usually water, and it consists of small amount of an electrolyte. Then we will heat that by supplying the electrical current, and upon heating the electric arc will be produced between these electrodes, that can be shown like this. So due to the intense heat, the electrical arc will be produced between these two metal electrodes. And these metals, if you consider you are preparing the gold sol, then ದಿ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಆರ್ ಮೇಡ್ ಅಪ್ ಆಫ್ ಗೋಲ್ಡ್. ಇವು ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಎದರಲ್ಲೇ ಮಾಡಿದ್ದು ಇರಬೇಕ್ರಿ, ಗೋಲ್ಡಲ್ಲೇ ಮಾಡಿದ್ದು ಇರಬೇಕು. ಅವಾಗ ಏನು ಪ್ರಿಪೇರ್ ಆಗುತ್ತಲ್ಲೇ, ಗೋಲ್ಡ್ ಸೋಲ್ ಪ್ರಿಪೇರ್ ಆಗುತ್ತೆ. ಇಫ್ ಯು ಆರ್ ಪ್ರಿಪೇರಿಂಗ್ ಪ್ಲಾಟಿನಮ್ ಸೋಲ್, ದಿ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಮಸ್ಟ್ ಬಿ ಆಫ್ ಪ್ಲಾಟಿನಮ್ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಆಗಿರಬೇಕು. ಈಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಸಪ್ಲೈ ಮಾಡಿದಾಗ ಅಲ್ಲೇ ಏನಾಗುತ್ತೆ, ಹೈ ವೋಲ್ಟೇಜ್ ಫಾರ್ಮ್ ಆಗಿ ಹೀಟ್ ಆಗಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಆ್ಯಂಡ್ ಹೆನ್ಸ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಆರ್ಕ್ ಈಸ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಇನ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟು ಎಲೆಕ್ಟ್ರೋಡ್ಸ್. ಆ್ಯಂಡ್ at that time, due to the intense heat produced, the metal will starts to evaporate. ಈ ಮೆಟಲ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಏನಿರುತ್ತಲ್ಲ, ಆ ಮೆಟಲ್ ಏನಾಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ ರೀ, ಎವಾಪರೇಟ್ ಆಗಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಬಟ್ ದ್ಯಾಟ್ ಮೀಡಿಯಮ್, ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಮ್ ಈಸ್ ಸರೌಂಡೆಡ್ ಬೈ ಐಸ್ ಬಾತ್. ಎದರಲ್ಲೇ ಸರೌಂಡ್ ಆಗೈತೆ ರೀ, ಐಸ್ ಬಾತ್ ಇರುತ್ತೆ ಅದ್ರ ಸುತ್ತಲೂ. ಅದಕ್ಕೆ ಏನಾಗುತ್ತಲ್ಲಿ, ದಿ ಮೆಟಲ್ ವಿಚ್ ಈಸ್ ವೆಪರೈಸಸ್, ಇಟ್ ಇಮಿಡಿಯೇಟ್ಲಿ ಕಂಡೆನ್ಸಸ್. ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಆ ವೇಪರ್ಸ್ ಏನಾಗ್ಬಿಡ್ತಾವೆ, ಕಂಡೆನ್ಸ್ ಆಗಿರ್ತಾವೆ. ಮೆಟಲದ್ದು ಏನು ವೇಪರ್ಸ್ ಫಾರ್ಮ್ ಆಗಿರ್ತಾವಲ್ಲ, ಆ ವೇಪರ್ಸ್ ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಕಂಡೆನ್ಸ್ ಆಗಿಬಿಡ್ತಾವೆ. ಆ್ಯಂಡ್ ಹೆನ್ಸ್ ದೋಸ್ ಮೆಟಲ್ ವೇಪರ್ಸ್ ವಿಲ್ ಗೆಟ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಥ್ರೂಔಟ್ ದಿಸ್ ಮೀಡಿಯಮ್. ಈ ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಮ್ ಒಳಗೆ ಏನಾಗ್ಬಿಡ್ತಾವ್ರಿ, ಇವು ಸ್ಮಾಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಗಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗ್ತಾವೆ. ವೇಪರ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಆದಾಗ ಆ ಪಾರ್ಟಿಕಲ್ಸ್ದ ಸೈಜ್ ಏನಾಗಿರುತ್ತೆ, ಸ್ಮಾಲ್ ಆಗಿರುತ್ತೆ. ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಕಂಡೆನ್ಸ್ ಆಗೋದ್ರಿಂದ, ಕೋಲ್ಡ್ ಆಗೋದ್ರಿಂದ ಅಲ್ಲೇ ಏನಾಗ್ಬಿಡುತ್ತೆ ರೀ, ಆ ವೇಪರ್ಸ್ ಇದ್ದಿದ್ದು ಸಾಲಿಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾವೆ. ಅವಾಗ ಅವು ಎಲ್ಲ ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಮ್ ಒಳಗೆ ಡಿಸ್ಪರ್ಸ್ ಆಗ್ಬಿಡ್ತಾವೆ. ಓಕೆ, ಆ್ಯಂಡ್ ಹೆನ್ಸ್ ವಿ ವಿಲ್ ಆಬ್ಟೈನ್ ದಿ ಗೋಲ್ಡ್ ಸೋಲ್. ಅವಾಗ ನಮಗೇನು ಸಿಗುತ್ತೆ ರೀ, ಗೋಲ್ಡ್ ಸೋಲ್ ಸಿಗುತ್ತೆ. ಆ್ಯಂಡ್ ದಿಸ್ ಕ್ಯಾನ್ ಬಿ ಡೆಮಾನ್ಸ್ಟ್ರೇಟೆಡ್ ಲೈಕ್ ದಿಸ್. ನಾವು ಈ ರೀತಿ ಅದನ್ನು ಏನು ಮಾಡ್ಬೋದು, ಡೆಮಾನ್ಸ್ಟ್ರೇಟೆಡ್ ಮಾಡ್ಬೋದು. The next physical method is peptization. So what does this peptization means? Peptization, it is the process of converting a freshly prepared precipitate into colloidal solution by shaking it with dispersion medium in presence of small amount of electrolyte. So ನಾವಿಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, precipitate ಇದ್ದಿದ್ದು colloidal solution ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ. Precipitate ಅಂತ ಹೇಳಿದ್ರೇನು, these are the undissolved substances which are present in an solution. ಒಂದು ಸೊಲ್ಯೂಷನ್ ಒಳಗೆ ಕರಗದೇ ಇರುವಂತಹ ಸಬ್ಸ್ಟೆನ್ಸಸ್ಸಿಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಪ್ರೆಸಿಪಿಟೇಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಸಸ್ಪೆನ್ಷನ್. ನೀವು ಇದನ್ನು ಏನಂತ ಕರಿಬಹುದು, ಸಸ್ಪೆನ್ಷನ್ ಅಂತ ಹೇಳಿ ಕರಿಬಹುದು. ಬಿಕಾಸ್ ದೇರ್ ಆಲ್ಸೋ ದಿ ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 1000 nanometer. ಇನ್ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಲ್ಸೋ ದಿ ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 1000 nanometer. One type, it is nothing but suspension only. ಈ ಪೆಪ್ಟೈಸೇಷನ್ ಪ್ರೆಸಿಪಿಟೇಟ್ ಅಂತ ಹೇಳಿದ್ರೇನು, ಸಸ್ಪೆನ್ಷನ್ ಅಂತ ಹೇಳಿ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಆ ಸಸ್ಪೆನ್ಷನ್ ಇದ್ದಿದ್ದು ಏನಾಗಿ ಕನ್ವರ್ಟ್ ಆಗಬೇಕು, ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಬೇಕು. ಆ ಕನ್ವರ್ಷನ್ ಮಾಡುವಂಥ ಪ್ರೊಸೆಸ್ಸಿಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಪೆಪ್ಟೈಸೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಪ್ರೊಸೆಸ್ ಆಫ್ ಕನ್ವರ್ಷನ್ ಆಫ್ ಪ್ರೆಸಿಪಿಟೇಟ್ ಇಂಟು ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ ಈಸ್ ಸೆಡ್ ಟು ಬಿ peptization. There we will use some small amount of electrolyte. Small amount of electrolyte add ಮಾಡ್ತೀವಿ. Now that electrolyte which is used for this purpose is called peptizing agent. Okay, it is here, it is missed. So that electrolyte which is used is said to be peptizing agent. ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, peptizing agent ಅಂತ ಹೇಳ್ತೀವಿ. So example for this type of process is ferric chloride. When it is added to freshly prepared precipitate of ferric hydroxide, it converts the colloidal soul of reddish brown. Okay, so here it is not peptizing agent. Okay, so what happens is ferric chloride, it is an electrolyte. When it is added to the ferric hydroxide precipitate, okay, it will convert into colloidal salt. Ferric hydroxide salt will be formed. ಈಗ ferric hydroxide precipitate ಅದ, ಅದಕ್ಕೆ ನಾ ಏನು ಆ್ಯಡ್ ಮಾಡ್ತೀನಿ, ferric chloride electrolyte ಅನ್ನು ಆ್ಯಡ್ ಮಾಡ್ತೀನಿ. ಮಾಡಿದಾಗ ಆ ferric hydroxide precipitate ಇದ್ದಿದ್ದು ಏನಾಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ ರೀ, colloidal salt ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಅವಾಗ ಅದ್ರ ಕಲರ್ ಏನಿರುತ್ತೆ ರೀ, ರೆಡ್ಡಿಶ್ ಬ್ರೌನ್ ಅಂತ ಹೇಳ್ತೀವಿ. Here initially the ferric hydroxide precipitate, it is consisting of larger particles, and when you add the electrolyte, it will attract the ions, okay, ferric ions to that ferric hydroxide surface. A ferric hydroxide surface ಮೇಲೆ Fe+3 ions or Fe+2 ions attract ಆಗ್ತಾವು, ಅಥವಾ chloride ions ಆದರೂ attract ಆಗ್ತಾವು. Okay, so when they will get attracted to the surface, it depends upon the type of precipitate. ಬೇರೆ ಬೇರೆ precipitate ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಬೇರೆ ಬೇರೆ ions ಏನಾಗ್ತಾವು, ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಾವು. ಈಗ ferric hydroxide ಸೋಲ್ ಒಳಗೆ ಸರ್ಫೇಸ್ ಮೇಲೆ ಸಪೋಸ್ Fe+2 ions ಅಟ್ರಾಕ್ಟ್ ಆದವು ಅಂತ ಹೇಳಿದ್ರ, ಇಲ್ಲಿ ಫೆರಿಕ್ದಾಗ ಏನಿರುತ್ತೆ ರೀ, here it consists of Fe+3 and in ferric also it is consisting of Fe+3. So what happens, the plus charge on surface as well as the ferric hydroxide also having Fe+3 and ferric chloride is also having Fe+3. So when it absorbs the Fe+3 ions on its surface, the repulsion will take place, and as a result of that the larger molecule gets broken and it will convert into smaller particles. ಏನಾಗತ್ತೆ ರೀ, ಆ ಲಾರ್ಜ್ ಫೆರಿಕ್ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಪಾರ್ಟಿಕಲ್ ಇದ್ದಿದ್ದು ಬ್ರೇಕ್ ಡೌನ್ ಆಗಿ ಸ್ಮಾಲ್ ಫೆರಿಕ್ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾವೆ, ಆ್ಯಂಡ್ ಹೆನ್ಸ್ ಪ್ರಿಸಿಪಿಟೇಟ್ ಗೆಟ್ಸ್ ಕನ್ವರ್ಟೆಡ್ ಇನ್ ಟು ದಿ colloidal solution. So simply remember, here precipitate gets converted into colloidal solution, and example for this is conversion of precipitate of ferric hydroxide into ferric hydroxide salt in presence of ferric chloride as an electrolyte. Okay, so here we can say ferric chloride is peptizing agent. Ferric chloride ಗೆ ನಾವು ಏನು ಹೇಳ್ಬೋದು, peptizing agent ಅಂತ ಹೇಳ್ಬೋದು. So remember this, and these are some physical methods to prepare the colloidal solution.